So today we're going to cover section 3 of chapter 3, and today we're going to be finding the zeros of polynomial functions. Another, I guess, way you could say this is to find the x-intercepts. So whenever they say find zeros, find x-intercepts, solve, find the roots, what we're doing is trying to find where our graph is going to touch the x-axis. So here is our first example. And I'm basically doing the same thing I did last night. I'm going to do a synthetic division problem, and if this is a factor, then my remainder would be 0. If I don't get a remainder of 0, then I'll say no, it's not a factor. So remember, what we need to do is to get the number we're going to use in the synthetic, I need to set this equal to 0, solve, and x equals 1. So this is the number that's going to go outside of my little L shape here. I'm now going to get all of my coefficients. So I have a 2. I'm missing the x cubed, so I put a 0. I have a 3x squared. That'll go there. Then the negative 5, and then the constant. Drop down the first term. Multiply. Combine 0 and 2. Multiply 1 and 2. Multiply 1 and 5, negative 5 plus 5, and then 1 times 0 is 0. Notice I did not get a remainder of 0, so you would say, no, x minus 1 is not a factor. On the next slide, it's actually describing what we're doing. It's called the factor theorem. So all you're doing is you're looking to see if you get a remainder of 0. If you don't get a remainder of 0, then the number that they're asking you to do the synthetic division with would not be a factor. So let's try another one. Same thing. Again, you're going to set x minus 1 equal to 0. So the x we're going to use is going to be a positive 1. Get all your coefficients here. So the 3, the negative 2. I don't have an x cubed. I've got an x squared. I've got an x, and I've got a constant. Drop it down. Multiply. Combine those. Multiply. Multiply, multiply. And again, notice I still did not get a remainder of 0. So this one is also x minus 1 is not a factor. So don't second guess yourself. If it doesn't work, it doesn't work. Now let's do it where the rest of them are going to work for us. Okay, so here we go. This time, instead of showing x minus x plus 3, they're telling us what x equals. So this time, see the wording on this? They're saying x equals negative 3. Is that a 0? So what we're going to do here, the factor is x plus 3, but the 0 is x equals negative 3. Because remember, when you set the factor equal to 0 and solve, this is how you get x equals negative 3. So this is the 0, this is the factor. So know the difference. All right, so let's go ahead and set up our synthetic. Again, I'm going to take all the coefficients. So I'm going to use the 6, that's the x cubed, then the x squared, then the x, and then the constant. Drop down the 6. Negative 3 times 6 is negative 18. 19 minus 18 is 1. Now multiply negative 3 and 1. Combine 2 minus 3. Multiply negative 3 times negative 1. And then negative 3 plus 3. This time I finally got a remainder of 0. So yes, this is a 0, or it is a factor. Now, notice the instructions here said to factor. I need to keep going. I've only found or confirmed one of my factors. So what I'm going to do now is I'm going to add the variables back in to this bottom row. So this is the remainder, this is the constant, the x term, and the x squared. So now I have 6x squared plus x minus 1. Now, my goal here, by trying to eliminate some of these other factors, is to try to get my equation into a quadratic equation that I can either factor, solve by completing the square, or using quadratic formula. Now, this one can actually be factored because that's what the instructions said to do here. So I can factor this. You can either do it guess and test. You could do the factors of 6, the factors of -1. That will FOIL back to give you that. Now, if you're not good at that guessing and testing, then you would do factor by grouping. So you would multiply. So I'm looking for two numbers that multiply to give me -6, but the same two numbers that add to give me 1. And those numbers are going to be 3 and -2. So if you're doing the factor by grouping, put the two factors you just found, make your groups, factor out the GCF, factor out a -1 GCF. Notice these two look the same. So I take one of them and then take the two GCFs. Now, if you're good at guessing and testing, you could jump probably right to this step. Now, it said to factor, so my factors here are 3x minus 1, 2x plus 1, and then the original one that they gave me. So if it says to factor, this is all we're doing. Now, if you were to multiply these three binomials, it would go back to your original function. You would FOIL two of them and then distribute it with the next one. Now, if it said to find the zeros, then I'm going to take each one of these factors and set them equal to 0 and solve for x. This will give me the zeros, which is where my graph is touching the x-axis. So I'm going to add 1. 3x equals 1. Divide by 3. X equals 1/3. Over here, subtract 1. Divide by 2. X equals -1/2. Over here, this is the one they originally gave me. So my three zeros are 1/3, -1/2, -3. Now, if you go back to the original problem, notice this exponent right here. This is going to tell you how many zeros we're looking for. So it's an x to the 3rd power, so this tells me I'm going to be looking for 3 zeros. Now, sometimes your zeros are going to repeat. It'll be like a bounce where it doesn't cross through the x-axis, it would touch and turn. So, however, in this particular problem, I did get 3 distinct zeros here, or 3 separate zeros, where my graph is touching the x-axis. So if it says factor, then you stop right here. If it says to find the zeros, then you take it one step further and set it equal to 0 and solve. So they're asking us, is this a 0? So again, we would do our synthetic division. We're trying to make sure we get a remainder of 0. So again, take your coefficients and do the synthetic division. Drop that down, multiply, 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 and I got a remainder of 0. So you would say, yes, x equals 1 is a 0. Okay, actually they told us it was. All right, so now my goal here is, because this original function has an x cubed, I can't factor that. that's not a perfect cube. So this is why I do the synthetic division to drop it down one power. So now I have a quadratic, because I'm going to add my letters back into this row. Remainder, constant, the x term, x squared. So now I take my 2x squared minus x minus 6, and now I need to solve this quadratic. And I can solve this quadratic by either factoring, completing the square, or quadratic formula. You can choose. Now, whenever I can factor something, for me, that's the fastest way. However, if you're more proficient at completing the square or quadratic formula, you can do that at this point. You can choose. Now, not all of the questions will be able to be factored because you might end up with an irrational 0. This one though, this is still factorable. I could do guess and test. These are small enough numbers. So my factors of 2 are 2 and 1. And my factors of 6, I'm going to use 2 and 3. So positive 3 and negative 2. Now, if you're not good at guessing and testing, then you would do factor by grouping. Now, at this step, I highly recommend that you FOIL these two and make sure that it does go back, because maybe your signs are off.
It's a negative x. So wouldn't that make the 3 negative?
Well, when I FOIL this, I get negative 4x
Oh.
and then 3x, and that gives me the negative 1x in the middle. Does that make sense? All right, so now I've got those factors. Don't forget, we had the one that they gave us, so we also have to take this one and write it down here. Now, if it said factor, we would be done. However, let's go ahead and solve these. Let's find where our graph touches the x-axis. So I'm going to take each one, set each one equal to 0, and solve. So now I'm going to do minus 3, 2x equals negative 3, divide by 2. My first 0 is at negative 3 over 2, or negative 1.5. I'm going to add 2. My next 0 is at positive 2. And then the last one is at x equals 1. And this is the one that they gave me. Again, they're giving me a 0. I know there's no instructions here, so we're going to factor it, and then we're going to find the zeros. So this is one of my zeros. This is what I'm using in synthetic. So negative 5. Again, take the coefficients. 6, 17, negative 63, positive 10. Drop down the 6. Multiply. Multiply. Negative 63 plus 65 is 2. Negative 5 times 2 is negative 10. Now, when they're giving you one of the zeros, if you don't get a 0 here, oops, you've done something wrong, okay? If they're already telling you that x equals something, the first time you do the synthetic division, if you don't get a 0 as a remainder, you've done something wrong. So if they're already telling you one of the answers, okay? The whole purpose of this is to drop this down a power so I can get a quadratic equation that I can factor, or use quadratic formula, or completing the square. So here is my remainder, constant x, x squared. So 6x squared minus 13x plus 2 equals 0. And again, this could be factored. We can do factor by grouping if you'd like. I know I jumped to the other way, but two numbers that multiply to give me 12, but the same two numbers that add to give me negative 13. So that's going to be negative 1 and negative 12. So 6x squared minus 12x minus 1x plus 2. Make your groups. GCF here is 6x. GCF here is negative 1. And that doesn't need a square. And now put the two GCFs together, and then this that was in common. Don't forget about the original one, the x plus 5. So again, if it said factor, we would stop here. If it says find all zeros, we got one more step. Set them equal to each other. I'm not equal to each other, equal to 1. No, equal to 0. All right, x minus 2 equals 0. X plus 5 equals 0. Add 1. Divide. My first 0 is at 1/6. X equals 2. And then x equals negative 5. And those are your 3 zeros. Again, they're giving me one of the zeros. So I'm going to do my synthetic division because I need to get this equation drop down one exponent. I need to make it quadratic so I can solve it. So again, we're going to put negative 5 here. Grab all your coefficients. And now divide. Negative 40, positive 10, negative 50, 15, and then 0. So now let's put back our variables. Remainder, constant, x squared. So 8x squared plus 10x minus 3. Again, this one can still be factored. Again, if it couldn't, then I would do quadratic formula or completing the square. So let's go ahead and do grouping, even though they're not that big. So factors in negative 24, that give me positive 10. So 8x squared, how about 12 and 2, and the 2 is negative. Next. So let's change this. So 8x squared, change and make this plus 12x minus 2x plus 1. Doesn't matter how you put them in there. Actually, my signs are off. Let's fix this. Let's make this a negative 12, positive 10. Right? No. Sorry, I was right to begin with. So plus and minus. Fix this. All right. All right, so now I need to factor by grouping. So GCF here is going to be 4x. So 2x plus 3. And I need to change this to a 1 or a negative 3. I don't know what happened there. Okay, so GCF here is negative 1. 2x plus 3 equals 0. Take the two GCFs, they go together, and then these things that were repeated. Write it once. Then the other factor is the one that was given, and that's the x plus 5. Now again, if it said factor, we would stop here, but let's keep going. Let's go ahead and solve these. So 4x minus 1 equals 0, 2x plus 3 equals 0, and x plus 5 equals 0. Add 1. 4x equals 1. Divide by 4. X equals 1/4. Over here, subtract 3. Divide by 2. X equals negative 3/2. And then lastly, go ahead and subtract and get negative 5. So those are your 3 zeros. Now, so far, it's been wonderful because they gave us a 0. It made it nice and easy. We did the synthetic, turned it into a quadratic. Now, the problem is not going to give you one of the factors, and we're going to have to guess and test and keep doing synthetic division problems until we get a remainder of 0. So the next slide actually has the rational zeros theorem. And what that states is to come up with possible zeros, we're going to take the factors of the last term and the factors of the first term and make all different combinations of possible zeros. Now, if your number is kind of large and it's got a lot of factors, you may have a lot of possible zeros. However, if your numbers are smaller, like say 1 and 5, your only factors you need to test are plus and minus 1, plus and minus 5. I'm going to show you what I mean by this. So here's my first example. It says to find all the zeros, which are the x-intercepts. Now, notice this time, they did not give me one of the zeros. So now I need to start doing a synthetic division problem, but I have to decide what am I going to divide by. And that's where the p cubed comes into play. Now, notice my exponent this time is a 4. So I'm actually looking for 4 zeros here. So let's go ahead and let me show you what the PQ stands for. So what the P is this is the factors of the last term. And this would be the factors of the first term. So for example, for the 2, the only way I can multiply to get a 2 is 1 times 2 and negative 1 times negative 2. And I'm going to write this with shorthand little notation here. I'm going to write it as plus minus 1 plus minus 2. Now I have to do the same thing for 6. The ways to multiply to get a 6 are going to be 1 times 6, negative 1 times negative 6, and 2 times 3, and negative 2 times negative 3. And again, I'm going to write this with my shorthand notation. So these would be all the factors of 6. Now that I have this fraction, I now need to start listing all of my possible combinations. So what I'm going to do is I'm going to take each one. Notice there's commas in between them. So I'm going to first use the 1 as a numerator and then put a 1 as a denominator. So really what I'm writing is plus 1 over plus minus 1. And this really, when I divide it, just gives me plus minus 1. Then I would take the 1 and put it on top of the 2. So then that would give me plus minus 1/2. Then I take the 1 and put it on top of the 3. And this gives me plus minus 1/3. Then I take the 1 and put it on top of the 6. Plus minus 1/6. Now, these numbers that I'm listing are possible zeros. They're all not going to work. Now, I still need to deal with the 2. So now I take the 2 and put a 1 underneath it. So I need to give all of these a chance to be the 2's denominator. So now I get plus and minus 2 over 1, which is just plus and minus 2. When I put the 2 over 2, that's 1. I've already listed it here. I don't need to list it again. Then I put the 2 over the 3, plus and minus 2/3. And then finally the 2 over the 6, which simplifies to 1/3. I already have it listed. So now these are all of my possible zeros that I could try to do a synthetic division problem with to see if I get a remainder of 0. So this is where the guessing and testing comes in. So now we technically, if you're a bad guesser, you have 2, 4, 6, 8, 10, 12 possible zeros here. Only 4 of them could potentially work because we could also get a radical as our answer if it can't be factored. So let's go ahead and let's see how lucky we get. I'm going to pick 1 and do a synthetic division problem. If I choose 1 and I don't get a remainder of 0, then I got to throw that one away, start all over again. Okay, so let's try it. So 1, go back to the original problem, and we need the coefficients. So I need 6, 7, negative 12, negative 3, and positive 2. Now, for the quiz, you're going to be using your calculator. So you're going to be able to see from the graph, and I'm going to teach you how to use a trace feature to find the zeros, even when they're irrational or rational, meaning a fraction. All right, so let's go ahead and do this. Let's see if we get a remainder of 0. Drop down to 6. Multiply and add. Multiply. And I get 1 and negative 2. And then negative 2. And I got lucky. I got one of my zeros. Now, keep in mind, there's still 3 more. Okay? Now, let's add the variables back. So we have remainder, constant, x squared, x cubed. So here's my equation. Now, notice it's still got an x cubed. I can't factor that yet, or use quadratic formula, or use completing the square because it's not an x squared. So I got to go back to my potential list here that's in green and do another synthetic division problem. Let's see how lucky we get. Okay? Just to save time, I've already done it. I'm going to say we're going to use negative 2. Now, instead of going back to the original coefficients, I'm using these coefficients now. This is my new equation because remember, you're trying to get the power to decrease. So I'm going to use 6, 13, 1, and negative 2. Now let's see if we guessed. Okay, let's see. 6, bring it down, multiply, combine, and I got a remainder of 0. I've just found 2 of my zeros. However, I still have 2 more, and I can find it by now using my quadratic formula, completing the square, or factoring. Remainder, constant, x squared. So 6x squared plus 1x minus 1. Luckily enough for us, this can be factored. Let's go right to the factored form. Factors a 6 and factors a negative 1. I'm going to guess and test. I'm going to do a 3x and a 2x, and then 1 and 1, and my negative will be here. So if you're going to guess and test, what you need to do is double check the outer and the inner. So negative 2x plus 3x, that did give me the 1x, so I did guess correctly. So now I've got 2 of my factors. My other 2 are the things that I did the synthetic division problems. So let me go back. So I have also this one. So I have x plus 2. And then I also have the x minus 1. These are my 4 factors of that polynomial. However, it said to find all the zeros. So now I set each one of these factors equal to 0 and solve for x. Add 1, 3x equals 1. Divide by 3. My first 0 is 1/3. My next 0 is negative half. My next one is x equals negative 2. And my last one is x equals 1. Those are my 4 zeros. All right, here we go. It says find all zeros. So again, let's do the PQ thing. So we need to put last over first. So my factors of my last term are plus and minus 1, plus and minus 5. My first term, luckily for us, it's 1. So my possible zeros are plus and minus 1, plus and minus 5. Now, not all 3 zeros could be these 4 numbers. We can also get irrational zeros, which is what's going to happen here. So let's go ahead and Let's get this down to a quadratic equation that we can factor. I'm going to use either plus or minus 1 or plus or minus 5 for my synthetic division. Here, these are the factors of the last term, which is the -5, and these are the factors of the first term, which is 1x cubed, so it's just 1. All right, so now I'm going to go ahead and do my synthetic division. I'm going to try 1. So again, take your coefficients, 1, 4. I don't have an x term, so I need to fill the gap with a 0. So let's see if we get a remainder of 0. Drop down the 1, multiply, multiply, multiply. And we got one of our zeros. Now I have a quadratic equation. Let's put the variables back in. So remainder, constant, x squared. X squared plus 5x plus 5 equals 0. Notice for this one, there aren't any factors of 5 that will give me 5. So this should be your clue that you either need to do completing the square or quadratic formula. I don't care which one you use. Now, I know you just practice completing the square a lot. You can do that. If you like quadratic formula, let me just review it with you.
That's -b over 2a, right?
No, that's the vertex form. So quadratic formula is -b plus or minus b squared minus 4ac divided by 2a. That's the quadratic formula. Or you could do completing the square. Either way. I could do it both ways just so you can see that you get the same answer. So here my a is 1, my b is 5, and my c is 5. So let's put it into the quadratic formula. So -5 plus or minus 5 squared minus 4 times a times c divided by 2a. So -5 plus or minus 25 minus 20 over 2, -5 plus or minus the square root of 5 over 2. These are your other two zeros in addition to x equals 1. So you have x equals 1, and then you have the two zeros that are right here because this is x equals when you use the quadratic formula. So if you want to write them apart, you can. I'm okay with you leaving it as plus minus. Now, let's say we did completing the square because you guys are so used to that. So let's say we did that. So over here, x squared plus 5x plus 5. So move the constant. Notice I don't have a y here. So I'm going to do it like we did at the beginning of the year. Divide the b term by 2, square it. So I'm going to add 25 over 4. So this becomes x squared plus 5x plus 5 over 2 squared. I need to find a common denominator here. So this will become 20 over 4. So then this becomes 5 over 4. So then I factor this. Square root. Yeah, that's a 5. All right, so now I need to square root both sides. So I get x plus 5 over 2 equals plus or minus square root 5 over 2. Move the 5 over 2. So x equals -5 plus or minus root 5 over 2. Same answer I got when I did it using quadratic formula. So here are my 3 zeros. Let me try one more where it doesn't factor. All right. So here, let's list our possible zeros. So we're going to do last over first. Factors of 3 or be -3 are plus and minus 1, plus and minus 3. Factors of 1, plus and minus 1. So my possible zeros are plus and minus 1, plus and minus 3. So let me go ahead and do a synthetic division problem. Again, I'm going to choose 1. You don't always have to choose one. It's usually the easiest one for me. So 1, and then no x squared term, the x term, and then the constant. Drop down the 1. 1 times 1 is 1. Multiply again, and I got a remainder of 0. So I found my first 0. It's x equals 1. So then now I've got a quadratic. So now remainder constant x squared. So x squared plus x plus 3 equals 0. And there aren't any factors of 3 that give me 1. So now you either do completing the square or quadratic formula. Quadratic formula again, just to review. These are my a, b, and c terms. So -1 plus or minus 1 squared minus 4 times a times c divided by 2 times a. -1 plus or minus 1 minus 12. -1 plus or minus -11 under the radical. Notice I'm going to get imaginary here. So I've got an imaginary root. So I get -1 plus or minus I square root of 11 over 2. So I actually have 2 imaginary rows here. I've got 2 imaginary. And then I've got the 1 real up here, the x equals 1. So I have 1 real solution and 2 imaginary. Your homework is, it was initially set up as 3.3a and 3.3b. I modified it because I looked at this. The 3.3b was only 4 problems. So instead, I've taken away the 3.3b homework, and you're just going to submit 1 homework for 3.3, and you're doing all of this. That was the message I sent you. So if you've already done it, make sure you go back and add in those 4 problems. If you just want to submit those 4. But at the moment when I changed it, there were only 2 people that had turned it in. Okay, so just make sure you're doing both sets of problems. That is your homework. Then tomorrow we're going to cover 3-4. We'll probably spend 2 days on it. It's going to be graphing these now. And we're going to try to find the x-intercepts. If you have your calculator, bring it. You for sure need it for Friday. Okay? You will need it for the quiz on Monday. It will be an all-calculator quiz. So make sure you have it for sure for Monday. But on Friday, we're practicing with it. I will not help you during the quiz with your calculator. So make sure you are proficient with the use of your calculator before you come to school on Monday. Okay? Because once the quiz is in front of you, I can't tell you what buttons to push.